Hey, how you doing there? Well, today we're going to learn core concept that is dynamic programming. First of all, what is mean by dynamic programming? It is a concept or the fundamental that we are using the previously calculated values to use that in future. Basically, we are storing every value what we calculate to use that in future rather than recalculating again and again. To understand this dynamic programming better, we solve one of the problem in the lead code, that is taking maximum energy from the Mystic Dongion. In this problem, the problem says there is a Dongion or tunnel. In that there are many number of magicians standing in a line. The magician gives you the power, but they may give you a negative power or even positive power also. The one thing is you have to get the maximum powers from the magician and you have to come out from the tunnel. Okay, but here there is one rule or condition, that is you have to jump key steps from the starting that what you choose. You have to jump the key steps from the starting step that what you are going to choose. If you, for an example, if you choose here 5, you may encounter with the magician minus 5, because your k value is 3. You have to jump 3 steps from this 0th index, that is 1 2 3. This magician give 5 power, that is positive, but when you encounter with this magician, he was taking the power from you. Okay, now what if I choose 2 here, that is 2 is in first index, so I'm going to jump 3 steps from the first index, that is 1 2 3. I'm encountering with the magician who's standing in the last of the tunnel or an array, that if I take power from this first index magician and the last index magician, that is last index, that is fourth index, if I take power from index 1 and index 4, my power will be 3. That will be the maximum power, because if I calculate from the second index, we cannot able to get another magician power. See, if I jump 1 2, I can able to just jump 2 steps. If I want to jump another step, I will go to out of bound, index out of bound. It is not possible in this case. Instead of minus 10 here, if there is an only positive 10, my maximum energy is 10, because I will get only from this second magician, that is second indexed magician. Okay, in this case there are magicians who give all negative energies only. In this case what I do is I take the last index minus 1, so that will be my maximum power. If I take, the rule is we have to take whether it is negative or positive. Here if I see the constraints, here there are array length of 10 to the power of 5, which is so big, and if we want to try and brute force, we may encounter TLE, that is time limit exceeded. See here I tried brute force having every possibilities and checking the maximum element with the current got element. This may lead to TLE, so I used this dynamic programming concept to solve this problem. How can I use this dynamic programming? In this case, I will show you. I will build an dynamic programming array, that is DP array, dynamic programming array, with the length of the energy array. I have a length of the energy array, so I can able to solve this problem. Okay, just imagine this is minus 1 minus 2 and minus 3. If I choose this last index, this is lesser than 3, right? So I cannot able to add, or I cannot able to get another power for this one. So what I do is I will just write here as 1, because here if I jump I cannot able to face another magician. Instead of that I will face an index out of bound error. So I will write 1 because I want to take the power from only one magician. If I choose the last step, what if I choose the -5 step? I am not going to get any power rather than -5 if I choose the last second step. So what I do is I just write -5 here in my DP array. So I'm going to take the another last third element, that is -10. Even if I take -10 now, I cannot able to get another magician, because if I jump 3 times, that will going to index out of bound error. So what I do is I just write this 10 as it is like that. And another one here, if I choose 2, the last fourth element is greater than 3, so I have to be little careful here, because after the last fourth element we have a chances of getting another magician, that if I jump 3 times here, I will get the last magician power also. So I will write here 3, because 2 plus 1 is 3. Okay, same as like that. If I choose 5, I'm going to encounter with this negative magician, the sum is 0. This is my DP array. If I choose the maximum element in this, what I get? The 3 is maximum in compare of the all elements, right? So I will write just here as 3. So in this case, our answer is 3. Okay, this is same simple as brute force, but just imagine what if there are multiple elements than this. Imagine there are 10 to the power of 5 elements. In that case, this DP else most, because we are just seeing the previously calculated value instead of recalculating again and again, which takes time more than what they given, right? So this dynamic programming is very important, and it is a very good concept. The man who founded this is a very legend.
Here, I'm using Java for to write code of this problem, which is related to dynamic programming. Okay, in first, I wrote here a max function to find the maximum element of the array. Even there is no inbuilt function. If it's there, it is complex to use. So I just wrote the method for myself to use it in this another method. So I am writing code here. Instead of calling the length function again and again, I will call one time and assign to the variable which return the size of an array. So, which is in type, I am going to declare the variable size and assign energy length. With semicolon, I'm going to write the another line that here I am declaring the one-dimensional array, that is DB. In Java, we can also able to write or declare a one-dimensional array even like this also, like how we write in C++ or C. I'm going to create a new instance which is array of that integer which consists of the elements as same as the length of the energy array. So I'm declaring the size of y in only in this particular test case. It depends in regarding of all the cases. We are just declaring variable right while come when the code getting compiled to this method approximate the value will come and the size will be automatically declared as you know all the concepts. So here what I'm doing is I'm iterating through this energy array that I'm writing the follow that I'm iterating from right to left and iterating from back. So I'm assigning size as my first iterate. I want to iterate from 4 because the fifth position is in fourth index until this I is greater than or equal to 0. Run this loop with incrementing this I value in every iteration. While this for loop running, assign dp lost lost index as energies Lost index. It is coming from lost first, right? So I said like this. Okay. Here, for these three elements, we just assign 1 minus 1 minus 2. But what for this 3 and 5 are the lost element which are greater than the 3? Here, the count is 1, 2, 3. For this 3 lost element, we are just assigning what? The same as the energy element. But what if the minus fourth element, that is minus fourth element, we have the next index that is 1, right? So we have to increment that value with the respective jumped value. That is, we are taking this one value from addition. So if this I plus this iteration plus k is lesser than is lesser than, right? We are going from here 4, 3, 2, 1, which is lesser than the actual size of an array, just increment this repeat I value again with this repeat what? Repeat I plus k value. We are just doing like this. We appending 2 plus this 1. We are just adding 2 plus this 1. And at next we are adding this 5 and minus 5. Even there are multiple events, this process will get continued. And at last, inside this public method and inside this maximum energy method, which is type of public, right? I have written the maximum element of this array. I wrote written before, so I am just returning maximum of this dp array. If I pass here, this method will be called. If I run this, let's see. Here all test cases got accepted. So here the final problem got accepted.